Welcome back to Ox Tools. I'm Tom. So today we're going to use an old Ellis dividing head like this to make something like this on the manual mill. And we're going to use a little bit of old school and a little bit of new school. So let's check it out. So how do you do that, right? So how do you generate a helix with a manual milling machine, right? So what you're actually doing is you're combining a rotary motion, which comes from the indexer, with a linear motion that comes from the milling machine. So somehow you have to coordinate the linear motion with the rotational motion. Now in the olden days, they used to do that by connecting the dividing head via a bunch of gear train basically, and they would couple that to the lead screw, which provides the linear motion. So what we're going to do is we're going to kind of modernize this idea a little bit and make the ratios easy to change and give some folks out there an idea how they can set this up and make things with helixes, drill bits, cutters, helical gears. You can do conical tapers. There's all kinds of interesting shapes that you can do with this. So let me show you a couple of pictures of how they used to do it in the olden days, and then we're going to go over to the mill and hook this thing up and make a cut. Well, if you're going to go old school, you got to have a couple of old books, right? So we've got, this is Audell's Machinist Toolmaker's Handy Book. This is this is actually a pretty good book. It's pretty readily available. There was like a lot of copies of this, but there's some great pictures in here. Let's just take a quick peek at this. I don't want to waste a bunch of time. So there's the gear train I kind of mentioned, connecting the dividing head to the linear travel of the machine. And there's an example of cutting a helical gear, kind of a large diameter one. They've got the cutter tipped over at the helix angle, and then it's cutting a helix. Now you can do spirals, stuff like that. There's another one, and you can see the gears. Here they're actually milling a worm. That's what they're doing there. So you can thread mill with this technique as well. So there's that. And then let's go. This is the Cincinnati Milling Machine Company. And let's see, that's not the one I want. There's their version of it. Now what they did was they spiffed it up a little bit and made a kind of a covered gearbox there, and had a hand crank so you could index it and do some stuff there too. And you would change these gears to change the relationship between the rotation and the linear motion. Now this has got some great examples in here. So there's multiple helical grooves. There is a form tool or a fluting tool that's they're making some gigantic cutter here, and they're cutting kind of the backside of the flute of the cutter there, which is pretty cool. And then some of you guys, okay, there's another cutter, and there's the gearbox. And some of you guys will recognize this one here. That's the rotor out of a Roots blower there, right? Which is a helical form, and they've got some kind of weird form tool in there that's kind of hard to see. Anyway, that's just, I just wanted to show you some examples of, there's a cool one there. There's a conical one there too, with a cone with a helix on it, okay? And there's how you would do that. And so anyway, I just wanted to show you some examples of the kinds of things that you might be able to do. So let's go in the mill and put this thing together. First things first, let's get the indexer on there. So we're just gonna whip this up on there. So, come on. course. There we go. All right. To align this, what I'm going to do, the side of this has been milled off here, so I'm just going to pick up the slot here, and this will get me pretty close. Okay, let's come back a little bit. Let's tuck that back in. Now we come over, and then we'll put some Snuggus McGee on there. Like so. And that's right, that doesn't I always forget about that one. It doesn't fit underneath there. Okay. Get that mess business out of there. Okay. Got the indexer up there now. Now, what we have to do is we're going to have to connect some pulleys and stuff here. Now, I made up all the brackets ahead of time, and this is the timing belt pulley that connects to this. So I'm going to get in a little closer, and we can see that process. Okay, so with the crank handle off, you can kind of see what we're working with here. So the crank handle engages these flats, and that's what gives you your drive there. We're going to leave the little butterfly on here and this index plate. But here's our timing belt pulley we're going to put on there, and this is how we're going to connect up the system. And you can see that I've cut a little pocket here, and these flats catch the flats of that. That'll leave me a couple of threads here just to kind of hold this thing on. So that's my driving kind of keys. And then, you know, this doesn't have to be like supercalifragilistically tight. And then I have the lock in here, but now we're connected. And I want to start on the 0 mark there. That's why I'm leaving that pin in there. So okay. And then the next phase here is this mounts our, and I can't reach it from here. We have a servo motor that's going to connect to that, and it could be a stepper, and that's going to pick up some holes in this plate like so. And then we're going to have a belt, this belt here, that goes between the stepper and the indexer. So let's put that on there. So this motor mount bracket mounts through this index plate like so. Got some small screws here to catch that. One. Oop, duh. All right, Mr. Wizard. Got it going the wrong way. Go like that, wise guy. Yeah, we had to, it has an offset towards the front, so. All right, I'm not going to put all the screws in here on camera. I'm just going to put a couple in to get started here. Like so. All right, and then what we have here is we have, this is a digital servo motor here. So it's got an onboard controller here that can store some programs. That goes like so. Actually, I'm going to put the other screws in there first. And I want to keep the connectors pointed off that way so any metal chips don't go in there. All right, so let me finish this up, and we'll get that motor on there. So I think we're going to do a disconnected demo here, I think. What I'm mounting right now is, this is the encoder, and this is an important part of this whole deal here, and I'm just going to mount that kind of loosely right now. But this thing is a precision counter, basically, okay, for lack of a better description. So this is counting and telling this how many turns to turn in relation to the turns here. So if this, in this case, the ratio between the hand crank and this is 1.75. So as we, this rotates a little slower than this does, or this rotates a little slower than that does. So is I guess what I'm trying to say. So let's see, Make sure I get this going in the right way here. I think that's the right way. Yeah, there we go. And we're gonna we got this chunky monkey ground here. It's gonna go on here. So, okay. Yeah, all right, I think I got it. And then I'm going to hook the power supply up, and then what we can do is we can rotate this and we can watch this turn here. So let me get that set up. All right, so put the power supply on just so you can see it moving here. We'll put a little piece of tape on there. A little flag. And then so this is the encoder down here, and it's going to be coupled to this hand wheel here, much like the geared system in the pictures that I showed you. But in this case, there you can see the motor turning in relation to that, right? Let's see here. Let me steal a little piece of tape off of that one there. I'm going to put that. Oop, yeah. Let's see. Put that on top. Put that on top. Yeah, like that. Okay. And then we'll put a flag on here so you can kind of see the relationship. So there's one turn. Okay, so one turn down here gives us whatever the reciprocal of 1.75 is. I can't think of what that is off the top of my head right now. Anyway, so that's the relationship right there. Okay, so let's get the rest of this hooked up here, and then we can actually drive the indexer. This is the pulley that goes on the motor here, and I had to come up with, these are some pulleys that we had around, and so what I did in this case here is I made kind of a collet arrangement here that has a taper. So bored a taper in that, matching taper there, happens to be 7 degrees. That fits closely on the shaft, goes in, and then when we pull it up with this nut, and that's split, you saw that, right? When I pull it up with this nut, it squeezes into the pulley and compresses that diameter and grabs the shaft nice. These motors don't have they don't have any flats on them or anything like that for set screws, and this was a kind of a hubless pulley, right? So I would have had to gone through the teeth to put a set screw in, and I kind of despise set screws anyway. So let's see here. So I'm going to get this belt on, and then I'm going to put the last little bit here. So this goes on the hand wheel here, or excuse me, the longitudinal feed, and connects to the encoder via a small belt too. So let me get that on, and then we'll come back. Okay, so we're all connected here. Let's see, make sure the shot pin's out of here. So now we are coupled from the x-axis linear travel to the rotational axis of this dividing head, and then we're just going to go ahead and rotate it for you there so you can see it. Okay, you see the head is turning, and I back up, and it kind of reverses that whole thing. Okay, so, and like I said, the ratio between these is 1.75, and this being the slower side. This ratio here is 40:1. So now, what it's set up for, it is currently set up for a particular helix, which is a 1 in 14. And what I mean by that is one turn in 14 inches of travel. Okay, so 14 inches of travel on this lead screw is 70 turns, so it's 40 over 70 or 70 over 40. That's the ratio, which is 1.75. What do I want to say? So as I turn this 70 turns, right? I get one full rotation of the 40:1 indexing head. Hope that makes sense. So let me put some material in here, let me get centered up, and we'll do a little cut, and you guys can watch. It's pretty fun. All right, I think we're ready here. I got a this is a piece of plastic here I grabbed. It's PVC pipe. And I have a 1/8 cutter here. Let's see. Sure, 1/8. And what we're gonna do, I'm just gonna eyeball a little cut in there, like so. Actually, I'll zero this quill. And so we're all coupled up. Let's see, I think we're ready here. Let's zero that. I'm on center line here. So let's just kind of get a try going here so you can see the behavior. So we want to take all the slack out in this direction, okay? And I'm just going to hand crank it initially. Yeah, okay, it's all right. And there it goes. So that's a 1 in 14 helix. Let me come up and make one pass. Let's come up to some even number here. I think I'm going to come up to 4 inches even. Right there. Now I'm going to lift out because I don't want to have any backlash issues. You know, it's partially mechanical, so now I can come up to my starting point again. Okay, and then I'm going to come a little deeper. In this case, let's go. I don't know, 30 thou deeper, and there we go. And so what we'll do is we'll cut a series of grooves around this, and I'll describe how I'm indexing it for the next groove, which, you gotta pay attention there. Mr. Bozo to visit us here. Okay, there's 4 inches. I'll come up, come back. Alright. So there's our starting spot again. And let me just double check. Yep, our shot pin goes in. So this is a 24 index, direct index wheel here. So this has holes in it going in this direction that this pin picks up, right? So as long as, in this case, that's what, every 15 degrees or something, right? And so we can do 15 grooves if we wanted to. I'm not going to do 15 grooves in this case. We're just going to, let's do 6. Okay, we'll do 6 grooves in this. And so the way I'm going to advance to the next groove is I'm going to disconnect the encoder from the hand wheel. I'm going to leave the table where it is, and I'm just going to rotate the motor until I drop into the 1/6 index hole, and then I'm going to reconnect the encoder. So that's a reasonably accurate index, you know. Now, if you got clever, you could set this up and have it index the correct number of turns, you know, for different divisions and whatnot. This motor setup is smart enough to do that. With, you know, maybe you need a little Arduino or something like that to do that. So let me. Well, let's see. I'm there. So why? Am I? Yeah, I'm there. Let's just disconnect this. I'm going to lock the table so it doesn't move on me. And then I'm going to loosen this, and you're going to watch it rotate. Okay. It'll take me a minute. Not like I got a nice hand wheel on this thing. All right, so there's my first mark there. Coming up. Come on. All right. Okay. Oop, and there it goes. Okay, so I'm in. So now I'm gonna relock the the retaining screws and take that out. And now I've indexed 1/6 of a turn, and we'll go ahead and start our, crap, I forgot how far down I went. I think it was 30, yeah, okay, let's do that. Okay, and I'm just gonna take the whole thing in one whack there now. And there we go. You know, and I can power feed this too. It doesn't care. I'm just turning it by hand because I can. Okay, there's 4 inches. All right, we'll come back. Go past, come back to our starting position, which is on the DRO here, right there. Okay, and then I'll index it another 1/6. To the starting point again, like so. Okay, yeah. Mark that hole there, so it's not every hole is marked. All right, so I'm gonna go ahead and yep, that goes in. I'm gonna index to the next 1, 2, 3. And there's my 4th hole. It's kind of interesting. You can, let me pull that out. Let's go back. There it goes. Okay. This is a 2,000 count per revolution encoder, right? So it's got a lot of resolution. So you can really get this to the sweet spot pretty easily in the shop pin there. So did I screw that up? No, I don't think I did yet. I don't think I did screw it up yet. Why am I off? That says 6. Whatever. I'm not going to worry about it for this demo here. Let's take another cut. There we go. So full disclosure, I bozoed one of the indexes, and so I cut another one so that I could have the I could have the money shot here. So anyway, anyway, I don't know what I did. I was talking and not paying attention. I didn't index it correctly. But there's the kind of stuff that you can do. Now, there'll be some improvements to this with a little box so that there'll be some adjustments so that you can change the relationship, the ratio between the motor and the lead screw, you know, the table movement. So you can change it from basically whatever you want. So this happens to be a 1 in 14, and we didn't do a full turn, clearly, because this isn't 14 inches long. But that'll be the next improvement on this thing. So anyway, I just want to show you guys this little thing that we've been playing around with, me and my friend Mr. Bill. He's responsible for the electronics part. and I'm responsible for the mechanical part and suggesting the idea, I guess, is the other part that I added to the mix there. So I hope you enjoyed it, and gets the creative juices flowing out there with all the little electronica guys out there thinking about this. So talk to you soon.